Okay, here's a couple problems from worksheet 4 that should help in studying for the quiz on Friday. All right. First, it asks us to determine the weight on the ball if it's in equilibrium. All right, so if we use this point right here as helping us to draw a force diagram. The weight is the force of gravity, so that's pulling down. We know that this force is the force. Let's call these two different strings. We'll call this one string number 1, and we'll call this one string number 2. So this is the force of tension from the first string, and this is the force of tension in the second string. So all three of those forces, when added together, would be 0. The only data we know is that this is 40 degrees, and tension 1 is 30 newtons. So it's useful that two of our forces are at the like on an axis. So we know that the force of tension 2 has two components, and the y component, Ft2 in the y direction, must equal Fg, and that Ft2 in the x direction equals Ft1. So together, Ft2 in the y plus Ft2 in the x give you Ft2. We know that this angle is 40. So to determine the weight, we need to know Ftx so that we can solve for Fty, so that Fty can equal Fg. So here we go. Ft1 equals 30 newtons, which means that Ft2 in the x direction has to equal negative 30 newtons. So that's this part right here. We know that 30, the sine of 40 degrees, has to equal 30 divided by the force of tension 2. So the force of tension 2 equals 30 divided by the sine of 40 degrees. 30 divided by the sine of 40. 30 divided by the sine of 40 is 46.7 newtons. So now that you know this one, 46.7 newtons, we can solve for Ft2y. So the cosine of 40 degrees has to equal Ft2 in the y direction divided by 46.7. So 46.7 times the cosine of 40 equals the force of tension 2 in the y direction, which is Ft2y is 35.8 newtons. Because we said that Ft2y equals Fg, Ft2y plus Fg is supposed to equal 0. They just have opposite signs. That means that Fg equals negative 35.8 newtons. That's the question. Determine the weight on the ball. So there we go. We did it. This is a pretty classic physics problem to put an object on a ramp and try to determine the magnitude of a force. So if we think about right away, the forces that are acting on this box, gravity always pulls straight down. The normal force always pushes up perpendicular to the surface. And in this case, the ramp is frictionless, but it's being held by a rope. So we have some force of tension that is pulling up the ramp. So for problems like this, where you have an object on a ramp at an angle, it's often a lot easier to rotate your system, because in this case right here, we have the force of gravity, which is on the y-axis. But both the normal force and the force of tension, they would each be at an angle compared to the y-axis or the x-axis. So if we rotate it so that the normal force is on the y-axis and the tension is on the x-axis, now instead of having only one of the three arrows on the plane, on the axis, now two of the three arrows are on the axis and only one is at an angle. And it happens to be that this angle of the floor is the angle between the force of gravity and the y-axis. So we can use that to help us determine the two components. So the problem tells us that the weight is 100 newtons, and it's asking for the applied force. In this case, we mean the tension. So what is the force of the tension acting on the box? Okay, so we've got the gravitational force, which we know, the angle, which we know. In order to solve for tension, the x component of the gravity is supposed to be equal to and opposite of the force of tension. So if we thought about a model for this, the force of tension plus the x component of gravity has to equal 0. And looking at this triangle, the sine of 30 degrees has to equal the x component of the force of gravity divided by the hypotenuse, which we already said was 100 newtons. So if you did this on your calculator, the force of gravity in the x direction would be 50 newtons. Because the force of gravity in the x direction plus the tension has to equal 0, that would mean that the force of tension is negative 50 newtons. Because the problem just asks for the magnitude of the force, you don't really even need this arrow, or I mean the negative sign. You could just say 50 newtons. Now, this question is asking if the arrow increased, so that would mean you got normal force, you've got tension force, and now, instead of this angle only being 30 degrees, if now this angle is 45 degrees, you can see that the x component has to get greater. It has to be greater in order to reach the end of it. So the force, if the angle were increased to 45 degrees, the F of G in the x direction would increase. We could do the math, and it would be the same process. This is still 100 newtons. So the sine of 45 degrees would have to equal FGX divided by 100. Okay, good luck on your quiz tomorrow.